Good morning, everyone. Welcome to our webinar this morning. It looks like we still have a couple people joining us, so just go ahead and get logged in. We're going to go ahead and get started. Today's webinar is Comprehensive Operational Review, which we call a CORE, for waste facilities. My name is Sarah Bolton. I'm the marketing manager here at Blue Ridge Services, and I'll be today's webinar moderator. So we want this experience to be really interactive. Neil will take questions throughout the presentation, and if you have specific questions related to your facility or specific aspects of your operation, please feel free to jump in at any time. This is for you guys, and we want you to walk away with some really valuable information. So that being said, before we get started, I just want to go over a couple kind of basic housekeeping technical items to make sure everybody's clear on how to use the control panel. So basically you have a control panel, and it might just look like these four little icons here. And if you want to open and expand the control panel to see all the options you have, you just click on the little orange button at the very top and it should open up. It should look something like this. Most of you, it looks like, are on the audio. If you are joining us via telephone instead of your computer, microphone, and speakers, make sure that you put your audio PIN number in. And if you don't know what that is, send me a quick chat and I can help you figure out what that is. And it just allows me to mute and unmute you in case you have questions that you want to ask. So the chat box is at the very bottom of your control panel, and you can send a direct message, a private message just to me, or you can send a message to the whole group. So if you have a question and you'd rather just type it and I can relay it to Neil, that's totally fine. Or the other option is you can click on this little hand icon that'll be on the left side of your control panel, and it effectively raises your hand next to your name. And I can unmute you and you can ask your question to the whole group. The other thing is the materials. There's some handouts that go along with today's presentation, and if you see the materials tab on your control panel, you can download the PDF directly to your computer and save it for future reference, or if you want to follow along with the presentation today. So just in case anybody cannot hear me, this is for anyone having audio issues. So they can just send me a quick message in the chat box and I can help them get audio set up after I get finished with this introduction. If you see a timer in the middle of your screen, you can just click on the edge of the box and kind of drag it out of the way. It just tells us how much time is remaining in the webinar. And finally, if you are interested in receiving continuing education units, CEUs, for this webinar, please get in touch with me. We can most definitely work that out, whether it's for SWANA or another organization. We usually have at least a couple people every webinar get that credit. So just hit me an email, sarah@blueridgeservices.com, and we can get that taken care of for you. So I think at this point, unless anybody has any questions you want to send me in the chat box, I am going to go ahead and turn it over to today's presenter, Neil Bolton. So I'm going to do that real quick, and he will get us started. Sorry, finding his name here. Okay. There we go. You on there, Neil?
Yes, sir. We're here.
Okay.
Hi, everyone. We are going to be talking about core assessments today. And the timer that Sarah talked about, we don't need to worry about that. We have as much time as we need to get through this. We've planned an hour, and I think it'll take just about that long. If we go a few minutes over, that's not going to be a problem. If you have questions, we'll answer questions as we go. You can just chat with Sarah and let her know, or raise your hand as she showed you how to do that, or you can save your questions for the end, but we won't leave until we've answered all the questions. So don't feel like if we take the hour talking that you're not going to be able to ask questions at the end. So today's webinar, again, what is a core assessment? Sarah's our organizer. We're going to do question and answer during the webinar, and just kind of as a personal side note, Sarah is my daughter, and she just had a baby on Thanksgiving, so everyone can just know that she's multitasking right now, taking care of a new baby and doing webinars. So she's definitely got her hands full right now. Okay, my name is Neil Bolton. I have more than 34 years experience in the heavy construction and waste industry, and we've been evaluating solid waste operations for many years around the United States, some in Canada, and actually some abroad. CORE, which we're going to talk about today, is an acronym that we coined for Comprehensive Operations Review. And that applies to, in our context, any solid waste operation. And that may include landfills or transfer stations or MRFs or compost facilities, even collections. So we'll talk about a variety of those things. And also I'll just give you a rundown on the process of how we do a CORE and what that actually brings to your operation. A CORE assessment evaluates the operational performance of a facility. It takes a look at how you're doing right now and provides recommendations to move forward. Essentially, it's a snapshot of your facility's efficiency. How are you doing? How is the planning working? How is your staffing working? But something that's important to keep in mind is that we're not so much looking at the people as we are at the process. Sarah, we have a poll question here. This I'll let Sarah explain how this works, but this just gets some audience interaction and lets us understand where everyone else is who's participating today. So Sarah, if you want to take this poll question, we can do that.
Yeah, absolutely. So I'm going to go ahead and launch it, and you guys will see a box pop up, and if you could just indicate your answer. And if this doesn't apply to your facility or you'd rather not participate, it's totally optional, and it's not totally anonymous as well. No one else can see what your answer is, but it just kind of gives us an idea of where everybody is at. Great, so we're at about 50%. I'll give everyone a couple more seconds to get an answer in. Okay, last chance. All right, I'm going to go ahead and close the poll, and we should see the results pop up. There you go. Can you see those results okay, Neil?
Yes, that's fine.
Okay, great.
So it looks like most have not conducted a comprehensive efficiency study. And this is something that, as we talk about this throughout the next hour or so, these types of analysis, efficiency analysis and process improvement, those are things that have been used throughout many other industries. You know, General Electric and Toyota and Ford Motor Company, General Motors, those folks have been evaluating and studying efficiency for decades. And so what we've done here is we've applied a lot of those techniques and processes, those analytical tools, we've applied those to the waste industry. And so that's what we're going to be talking about in the next little bit. Every operation has room for improvement, and the current economy has made that even more important, more critical. So first off, let's talk about how we got here. How did we get to a situation where we have inefficiencies in our system? Sometimes, and we'll go through the list here, and sometimes that happens when times are good and the tonnage is coming in and there's lots of revenue, that we buy extra equipment and we get a bit sloppy in our operations. And we do things and don't really pay much attention to it because it doesn't matter. We're making money anyway and everything's working. Sometimes it's tradition. You'll find that most of your staff, most of your crew that works at a landfill, a transfer station, at whatever facility you have, most of your crew learned to do things by the person that was there before them. And so we do things a traditional way. One of the ways that we get here to this point of inefficiency is not having good real-time feedback. For example, we may look at in a landfill situation, our cover ratio, and we may do that annually when we fly the site. And so we may find that when we fly the site, we have a 3-to-1 cover ratio. If you're in the landfill business, you know that's pretty typical. But what that doesn't show us is the performance day to day in terms of where we are. And what we'll find when we look at detailed information is that there's a lot of variation out there. So lack of real-time feedback really doesn't let us pinpoint where we are doing well and where we aren't. Sometimes this problem comes from just operating in a bubble where we don't get out and see other facilities, we don't have a broad perspective, and so we just think we're doing well because it's the way we've always done it, and our numbers are consistent year to year, good or bad. Sometimes we don't ask the right questions, or we're just following our own standards. It can just be a habit. Number 5, we talk about desire to do the best possible job. Sometimes we build inefficiencies into our system because we're trying to do too much. We're trying to not only comply with regulation, but perhaps over-comply. Or we're trying to not only provide good customer service, for example, not having trucks wait at all as they come into our transfer station or into our landfill, but getting them out as quickly as possible, not realizing that we're adding a lot of staff and equipment and cost to be able to do that. Sarah, here's another question. Let's go to this polling question and get some answers on this.
Okay, great. So I'm going to go ahead and launch this one. I'll give you guys a little bit more time because it's kind of a lot to process. But basically, it's just asking what is one of the most common contributors to your inefficiency. And you can just kind of choose an option that maybe makes sense for your facility. And again, if it doesn't make sense or you don't want to participate, feel free to just sit this one out. All right, so we're at about 50%. I'll give everybody a couple more seconds to get an answer logged in. Okay, last chance. All right, so I'm going to go ahead and, I'll wait just a second. A couple more answers are coming in. Okay, so I'm going to go ahead and close this poll, and Neil, you should see these results pop up.
Okay.
There you go.
Well, what we see here is that by and large, it's tradition. It's the way we've always done things. And we're all used to that. If you put a sticky note on your computer to remind yourself of something, you notice it today and you notice it tomorrow and you might notice it for a few days. But after a few weeks, you don't even see that because you become so used to that. And we have traditional inefficiencies in our operation that we just simply don't see because they have become normalized. We're so used to doing things a certain way that's how it is. And so part of the process of doing a core and evaluating your system is to step back and ask, what is the big picture goal? What is the strategy here? Where are we headed? And see if we can find some other ways to do that. And one of the things that has helped us to be able to do this is that we've visited hundreds of waste facilities around the country, and so we have a pretty broad perspective, and that helps us to get kind of a broad look at how things are going. Okay, let's go on to the next slide here. This is the agenda, what we're going to look at today. What is a core? What are some various productivity analyses? What types of techniques do we use to evaluate your productivity, your efficiency? How do we measure the process, not the people? And so I can share with you, when we do core assessments, very often there's a lot of uncomfortable feeling on the site because somebody's coming in from someplace else and he's going to watch what we're doing and everyone gets nervous. But by and large, we are not looking at individuals. Our focus is on the process. And so if we talk about the dozer, we're not talking about the dozer operator. We're talking about the process that the bulldozer does. Or if we're talking about a route truck, we're not necessarily talking about that particular driver. We're talking about the process. How is that whole system working? So we're going to go through some examples for different types of waste facilities and hopefully give a broad picture of how this all works. The core methodology, the systems that we use, the analytical techniques we use include lean engineering and Six Sigma. Six Sigma is a way of minimizing errors in a system. So when we do things and there's inherent error in our activity or in the process, Six Sigma helps us identify what those are. We use time motion studies and activity sampling and value stream mapping. We'll talk about some of these, not in great detail, but we'll talk about these throughout the next 45 minutes or so. The key is that we want to be able to really measure the operation. Peter Drucker, the late Peter Drucker, once said, you can't manage what you don't measure. And that is true, but a core assessment is not benchmarking. Benchmarking is when we track performance, we track our cover ratio, we track our payload for our trucks, we track hours, we track tons, we track a variety of different things. That's benchmarking. We try to measure things. But too often when we measure those numbers, we don't know what to do with the results. So benchmarking basically shows the effect. It's the result of what we're doing. But what we want to do is identify how we're doing things, where there are inefficiencies, and then try to find ways to deal with those root causes, because that's where the change comes about. Sarah, let's send this polling question out. Which performance indicators do you track? Now, some of these may not apply to your facility if you're doing collections or you're doing composting, and so if some of these don't apply, don't worry. But if you can answer some of these, go ahead and do that, and we'll get a look at what type of indicators you track.
So yeah, go ahead and you guys should see that box pop up, and if you want to just go ahead and put your answer in. Okay, so we're at about 50%. I'll give everybody a couple more seconds to put an answer in. Okay, we have a couple more answers coming in, so I'll go ahead and wait. Okay, last chance. All right, I'm going to go ahead and close the poll. And Neil, you should see those results pop up.
Okay, we see machine hours and labor hours kind of leading the pack. And I apologize, the way this question is set up, I'm sure some of you are saying, hey, we track machine hours and we track labor hours and we track all these different things. So this isn't a true indication of the extent of tracking, but it just gives us a feel for maybe where some of the priorities are. And certainly these two things, machine hours and labor hours, are important. They form sort of the basis for any other analysis. And there are lots of other benchmarks, lots of other measurables that we'd want to look at, but machine hours, labor hours, tonnage, those are key foundational indicators, and we always start with those. That sort of defines how much work has to be done and generally how we're doing it at the current point. The key is, if we're not making our numbers, we need to find the root causes. We need to find those factors that are affecting our operation. And we can't do that by tracking numbers. You know, you can look at your airspace utilization factor, for example, at a landfill, or you can look at the percentage of sendbacks you have to do for your collection facility. How many missed pickups do you have every day, and what's the percentage of that? And you can track those numbers, and you might be able to see what's changing year to year. But if you don't delve in and find the root causes of where those numbers come from, you can't really make change. All you're doing is monitoring your performance, good or bad. Here's a common effect for landfills, probably the most common effect and one of the largest costs, unnecessary costs of operating a landfill. And that effect is using too much cover soil. So here's one way of evaluating that, and that's to use what's called a fishbone diagram or a cause and effect diagram. And I think we have that a little bit bigger here so you can see it. What that is, you identify what the issue is. On the right-hand side, we say, well, this is poor cover ratio. We don't have an effective cover ratio at our landfill. So then the blue boxes on the top and on the bottom are broad categories. If we start at the top right, maybe we don't have some established cell construction procedure, or next maybe we have variations in cell, I'm talking daily or weekly cell quality. Maybe we don't have good management guidance or improper soil placement method. And once we identify where we think that the main problem is, then we go deeper and we identify, for example, if we go to the bottom right blue box, excessive use of soil on tipping deck, there are some reasons that we might have that happening. Loads are dumped too far from the face, or the dozer blade is carried too low and we're carrying soil into the cell with every push, or the spotter is not segregating loads. I see here we've got high percentage of bulky waste in there twice. That must have been a really, really important one. Anyway, this is a tool, a cause and effect diagram or fishbone diagram is a tool for helping us zero in on what the real cause of that is. Because for us to track our cover use year to year, when we do our annual flyover, might give us numbers and we can track that, but it does nothing to help us improve what that cover ratio is. So this is just one tool to be able to zero in on that. Here's the procedure. Normally, when we do a core, when we conduct a core assessment, there's some site reconnaissance involved. There's a lot of data gathering. We do some modeling. We have a model that we've developed over the past couple of decades. We call the Landoff model. And it's an Excel-based model. It has about 100 interactive spreadsheets. And what that does, it just helps us take all of that data, input it, and then see how it interrelates. I'll talk about that more in just a bit. We try to optimize key tasks, and then we report that. The Landoff is, as I said, is an interactive spreadsheet. It has 100 or more worksheets within the entire spreadsheet. And so, for example, if we're looking at optimizing waste compaction, we would want to know what the landfill airspace value is, how many tons per day comes in, what the production rate is of the compactor, and to know that we need to know also what the compactor's hourly cost is, and all those things are interrelated. And so once this spreadsheet, this model is set up, if something changes, if we say, hey, wait, we have diesel fuel in there at $3 a gallon and it looks like it's going to go up to $4, we can make a change and put diesel at $4 a gallon, and it changes the entire spreadsheet. It changes all of our equipment owning and operating costs, all of our production rates, and those kind of break-even points where we optimize productivity. It changes all those, and so it's an interactive spreadsheet. It just saves us a lot of time when we go through and analyze this stuff. This just kind of explains how we do that. So we'll insert not only data from your site like tonnage and equipment hours and those sorts of things, but also findings from our production analysis. So if we do time motion studies, we'll take a look at how that implements in here. Here's an example of a time motion study, kind of a time study for the process of a dozer pushing trash from where it's dumped to the face, to the active part of the cell. And what we're looking for normally with this kind of data is normal distribution. We're looking for a bell curve. And in this particular case, we don't see that. We see data scattered all over the place. And so the typical or average push time might be 43 seconds, but we see that some pushes take 3 minutes and some take 10 or 15 seconds or less. And that kind of variation means that there's a problem. It means that we're not doing things consistently, and that could be differences in different machines, different operators, different loads of waste, but it's a problem. So this kind of data shows us what's currently happening at a landfill. Let's talk about this. Pushing to the face, it's a simple task. So let's just discuss what happens with the D8. What's the maximum payload for D8? How long does it take to make one push? And we can figure out what that production rate is. And here's what we often find. Let's just imagine this. We've timed hundreds of solid waste operations, and typically for a dozer, let's say a D8 in this case, to push trash from where it's dumped at the edge of the tipping pad to the face, spread it, and back up and get ready for the next push. That complete pushing cycle takes about a minute. And normally, a D8 can push more or less tonnage, depending on the type of load. But if we say 7 tons average, that means that dozer can push 7 tons in 1 minute. And if it could work at key production, at peak production all day long, or for an entire hour, it would produce about 420 tons per hour, or approximately 400 tons per hour. That would be its peak production rate. And so what we find is, pretty often, for example, a landfill that is open 10 hours a day, we'll find that dozer may work all 10 hours, but really, if we're taking in, say, 1,000 tons a day, that dozer only has to work about 2.5 hours of peak production time. And of course, the garbage doesn't all come in that way. It's not an assembly line, it's a landfill. But when we find a machine like this dozer that has a potential production rate of 400 tons per hour and it's performing at a fourth that, sometimes less, it tells us there are lots of other things that it's doing that are not productive. And so that points us in the direction of where we can look. We'll talk a little bit about value stream mapping in a bit and kind of that process of how that works. That's another tool that we would use. Okay, I'm going to skip through this. Here's a list. Here are some things that that dozer operator does with every push. He's watching traffic and he keys off the spotter. You can read the list. There are lots of things that have to happen. But within that, the key process is to push, spread, return. and then do that over and over and over. And what we find is there are lots of things that happen out there. Some of it's traditional, where a dozer operator may, in between loads, when there's nothing to do, go find something to do. Go backblade an area or push waste someplace where it doesn't need to be pushed, or do some cleanup pushes that are not productive. And keep busy because, hey, that's his job or her job to operate the dozer. And so they're going to do that all day long because that's what they're assigned to do, instead of focusing on making only production pushes and only doing work when there's work to be done. So when we talk about value stream mapping, the ideal process is that we only push, spread, and return. We do only what's necessary, and we get rid of some of these other non-value added activities. Here's some activity sampling results for a bulldozer. It's based on 564 samples or snapshots of what the dozer is doing, and it's within a 4% margin of error. And what we see here is that the green parts of this chart, and I think I have a better one here, the green parts of the chart are value added. They're things that are important. They are, starting at the top, installing or uninstalling tarps, pushing ADC, pushing a full load, pushing cover soil. So the darker green parts of this are the value added activities. They're the things that need to be done and should be done. Then as we get into lighter green, we see that sometimes the dozer is pushing a partial load or pushing a very light load, or the backing up. Of course, there's some backing up required, but repositioning and compacting and trying to do other things that are not value added. What we find is that a very small part of what a dozer does is actually productive work. And so that's a traditional thing. If you tell a person they are the dozer operator today and that's their assignment, they're going to stay in that dozer, they're going to work all day, and they're going to find something to do in that dozer because that's the job you gave them. That's a good trait. But what we want to do is retrain the mindset of folks so that they only use that machine productively, and when there's nothing productive to do, that they don't do anything. They get off and they get on another machine, they get on the water truck and run a load of water for dust control, they clean the tracks, they help direct traffic, they pick up litter, they do something else. And this pie chart here, this activity sampling chart for the bulldozer is very typical. We typically will see that a bulldozer spends only a small part of its time actually in productive work. So once we figure out what the optimum dozer production rate is, we can come up with some realistic benchmarks rather than tracking your performance. And some of you noted that you track your equipment hours, and that's an important number to track. But if you only track your equipment hours, what you're doing is monitoring the inefficiency that's in the system rather than zeroing in and finding out how much that machine should work and then focusing on that so that you can set some actionable benchmarks. The goal of this whole process is not to benchmark. Benchmarking just helps us measure. The goal is to get top performance, to make us as efficient as possible. The analysis shows us how to get there by zeroing in and finding those details that tells us how to get there. Let's talk a little bit about wood and green waste. There are lots of inefficiencies in this because the material is handled so many times. Typically, we find that wood or green waste processing operations will touch the material. They'll handle it 9 to 14 times. Some more, some slightly less, but this list kind of gives an example of that. This shows chronologically where a load of wood or green waste would come into the facility, be dumped and sorted and pushed into a bin or loaded into a bin and hauled to a wood pile. And then that's pushed up into a bigger pile. And then at some point we extract it and grind it, and we push up what we've ground into a pile, and then we may screen that, and we may push that up and then load it into a truck, and then haul it to a cogen plant or haul it back to ADC or take it to the compost area or whatever we're going to do with that. When we see a process where the material is handled this many times, it's begging for an efficiency analysis because there are a lot of opportunities to cut processes out, to shorten processing times. Every time we touch that material, it costs money. And so doing time studies, assigning costs, and looking for savings is an important way to do that. When we talk about a time study, it's how long does it take us to grind material? How long does it take us to haul it to the wood location? How long does it take us to haul it back to where it's going to be ultimately used? Here's some solutions, and we'll talk about each of these individually. Eliminate some of the steps. Is there an easier way to process green waste for ADC. Now, some landfills will use green waste or wood waste as ADC, and very often they'll process that. ADC, I'm sorry, is alternative daily cover. It's an alternative to soil cover that a landfill might use to cover the trash. And so processed green or wood waste can sometimes often qualify as ADC. So the typical process is that material goes through those steps we talked about. It's ground up and eventually it's hauled to the face and it's placed as ADC. But we've seen some landfills that will actually place that material near the face, just unload the loads of brush and pallets and that sort of thing near the face. And at the end of the day, or sometime during the day, the compactor will go over and crush that material and roll back and forth across it, and then that material is dozed on, pushed onto the face as ADC. And so there are very few steps. The material is not picked up. It's just dumped close to where it's needed, and it's processed right there. So sometimes eliminating the process or a step in the process can save us some time and some money. Sometimes we can shorten the haul distance. Remember, the further you haul it, the more it costs. Here's an example. Again, if you're processing wood or green waste as ADC, some landfills, some transfer stations, some compost facilities, wood and green waste processing facilities, they have an issue where they will, at startup, when the facility first began operation, they may identify a specific area for processing green or wood waste. And as the facility grows, that may not be the right area. And in the landfill, here's what often happens. We have a wood waste or green waste area. That's where it's dumped. It's always been there. It's that tradition. We keep dumping it there. But eventually the landfill develops, and now, years later, the landfill operation could be half a mile away. And so we're still dumping that material in the same place. We process it, and we pick it up and haul it half a mile to the landfill to use it as ADC. Better sometimes to reevaluate and relocate those processing areas so that they're close by. Reassess the layout. We recently worked on a project where the green waste facility had grown considerably from when it started, and they had an area where they dumped the raw material. Customers came in and dumped green waste, and they had a place where they processed that. And adjacent to that, directly adjacent, they built compost windrows, and they processed it there. They composted it, and that worked. But over time, they found that they needed more and more area for the composting operation, more room for windrows, so they developed a piece of property adjacent and several hundred feet away from the original location, yet they didn't relocate the drop-off area. And so they were processing material and picking it up and hauling it to the compost windrows and costing the operation a significant amount of money because they just were stuck in those traditional locations and not stepping back and realizing that there's a more efficient way, there's a way to shorten the haul distance. Also, consider ways to make the customers transport material. That can apply to a green waste facility or a transfer station, or even for a landfill. Some landfills have areas where they stockpile soil, and so any free soil that comes in gets dumped in a stockpile. And that location is usually fixed, and it usually stays in the same location for a long time. But wouldn't it be better to have customers who have loads of soil that you can use as daily cover go directly to where you need cover that day and place that soil in the right place? Sarah, we have another question, and this refers to just kind of your own interpretation, your own expectation of where you would expect to find the greatest inefficiency in your operation. Where if you had a magic wand and you could make some part of your operation more efficient, which one of these three areas would you focus on?
Okay, great. So you guys should see the poll box pop up, and if you want to just go ahead and indicate your answer. And this is kind of the area where you would expect to find the greatest inefficiency. So some of you might, again, this could be a multi-answer question, but just, choose the one that you would expect to find the greatest inefficiency. And we're at about 60%, so I'll give everybody a couple more seconds to get an answer in. Okay, a couple more seconds. Okay, I'm going to go ahead and close the poll. and share these results. So Neil, you should see those pop up.
Okay, equipment utilization is the top answer, followed by material handling, and at the end, labor. And that's pretty typical. That's often what we find, is that equipment is not properly utilized. What we see is that typically at a transfer station, at a compost facility, at a landfill, even for a collections system, when things aren't working well and we're not keeping up with the workload, the first thing that we look at is, do we need more equipment? Do we need more trucks? Or do we need more people? And so we'll add those. And instead of stepping back and looking at the inefficiencies and where we can maybe reduce some of that equipment overhead, we just keep throwing equipment at it. And that's easy to do during the good times when there's lots of tonnage and lots of revenue, and it catches up to us during the slow times. So this is pretty typical. The results of this are pretty typical. But I'll just note that material handling and equipment utilization are integrated. They're one plays off of the other. And so if we have equipment utilization issues, we'll normally find that there's some material handling problems and vice versa. Something to note on the labor, pretty often when we do a core assessment, there's concern that we're going to be eliminating jobs and people are going to be out of work, and that's normally not the case. What we find is that once we go through and do an assessment, when we make things more efficient, we are actually reallocating the labor. Every facility, every operation has those wish list things that you just can't get to. If you had some more people, boy, you'd sure like to be able to do such and such. And so by reallocating that, making certain things more efficient, we're able to do that. Okay, let's talk a bit about collections. A core assessment of a collection operation is not a route survey. It's not a route optimization, although that may fall out of that. There may be some of that that comes out. It's an assessment of productivity. It's a look at specific tasks, specific parts of the operation, to see where there's inefficiency or lack of productivity. So does your collection operation have hidden costs? You bet it does. You bet it does. Here's an example. Many landfills, in order to speed up truck unloading in the name of customer service, they'll establish a clean-out area, a place where trucks come in, they back into the edge of the face, the edge of the cell, right at the edge of the tipping pad, they unload, and then they quickly, the landfill policy quickly has them pull out to some other clean-out location. And the idea is that if you get those folks out of there quick, then the next truck coming into the landfill can dump. And so in terms of getting the folks, the inbound trucks, in quickly to dump, this works, but it's often counterproductive. So the clean-out area becomes kind of a talk zone, a visit zone, and we do a lot of video filming at landfills and transfer stations and other operations, and we typically find that this is a real chat time. And so trucks get in and dump quickly, and that gives the appearance of good customer service because no one's waiting. And then we find a lot of the vehicles, primarily commercial drivers, will stand and chat and talk for 15 or 20 minutes. So it's a good idea, but it does not work. We've found that it's typically better from the landfill's perspective and from the collections perspective in terms of getting drivers in and out quickly so we're not wasting time on a route, is to not provide a clean out area and make changes at the landfill so that it's safe for the trucks to clean out at the edge of the face where they unload. But what happens is, psychologically, when they've got to clean out right where they dump, and there's no place to stop and chat, and they look over and see a line of vehicles waiting to get in, it puts some peer pressure on those drivers to get cleaned out quickly and get out of there because somebody else is waiting to dump. Once we build a separate clean-out area, we not only make more mess for the landfill to clean up and increase those costs, we really are doing something counterproductive in terms of getting the route trucks or transfer trucks in and out quickly because it's a time to visit. Often, when we're doing this analysis, we will do something we call unit changing. That's a term that we came up with, but essentially, we might do a time study and indicate that, find that on a route, the typical time to return and pick up a missed stop on a route is 12 minutes. And we might say, hey, that's 12 minutes, that's no big deal. But when we start looking at that in terms of the cost, that 12 minutes costs us $26 or whatever it happens to cost, it takes on new meaning. And so if we have 10 missed pickups a day, and we're thinking, well, take 12 minutes here, run over and do this, and we just assign someone to it, no big deal. But when we realize that those 10 missed stops cost us $260 a day, it puts a different perspective on things. And so we find that in evaluating this, different types of operations, we will change units. We will look at things from a different perspective to try to see if something will pop out that we've been blind to before. And also, in presenting this type of finding to your management team or to your crew, by assigning cost to it, can really help make the point of how important these specific efficiencies are. Another example, in a landfill, it's easy at the end of the day for a scraper operator or a truck driver to just go get one more load of dirt because they're on the truck and it's not quitting time yet, and so they want to keep busy, so they're going to haul another load. But we find often that extra load of soil, in terms of the cost to haul it and the airspace it consumes, might cost the operation $200, in some cases $300, but it's a significant cost. And when we share with operators that here's the true cost of your decision, it helps them be proactive in this whole process too, for continually looking for process improvement. Sarah, we have another poll question. This is just a gut feeling. You don't probably have numbers for this. How much do you think you could save by streamlining your operation? If you could get the inefficiency out of your system, what sort of savings do you think you would realize over the course of a year?
Okay, so you guys should see that poll box pop up again, and if you just want to choose the answer that kind of makes the most sense. And like Neil said, it's just kind of a guesstimation. You probably don't have specific numbers. So we're at about 60%. I'll give everybody a couple more seconds to get an answer logged in. Okay, last chance. I'm going to go ahead and close the poll and share the results. And there you go, Neil. You should see those pop up.
Okay. Well, we're seeing most of the results in the less than 200,000 or somewhere under $500,000. A few indicating higher potential savings. And normally, just as a point of reference, what we normally find, say in a landfill core assessment, is that typically, unless it's a very lean operation going in, we typically find that the lead equipment, the dozers, compactors, scrapers, or trucks, those machines aren't being used efficiently. And in the case of the dozers, typically we're putting in 2 to 3 times more dozer hours per day than are necessary. So there's usually significant savings in the equipment. We also find that the material flow is a problem. We find there's a lot of wasted effort or wasted motion in material flow, whether it's at a transfer station or a compost facility, where material is not being moved efficiently. We also find that in trucking operations, collections, transfer, trucking, whatever trucking you're doing, is that payloads and cycle times are normally pretty strong indicators of problems. And if we looked at an annual average of payload or annual average of cycle time, we might see things looking pretty normal. But when we look at individual cycles, individual loads for payload, there's often a lot of variation out there. Let's talk a bit about recycling. Excuse me. When it comes to using this process improvement whole approach, a MRF or a recycling facility is a factory. I don't know if you've ever seen I Love Lucy when she and Ethel were trying to wrap those little chocolate candies coming on the conveyor belt. That is the classic factory analysis of what is the process. How can you streamline a process? And a MRF, recycling facility, is exactly replicating that. And so we have material handling, we have specific processes, we have a lot of things that can be analyzed. One of the questions we look at when it comes to recycling is the cost. You know, recycling costs money, and that doesn't mean it's bad, but typically recycling costs more than it generates in many cases. Not always. Some recycling facilities make money, a lot of them don't. And so often it's absorbed into the system that recycling is just something good to do, it's politically correct, it has environmental benefits, but it costs money, and so we do that. But if you stepped back and looked at your recycling or your diversion program and did a cost-benefit analysis, not of the whole system, but of individual components, you might be able to reevaluate where you put your effort. So here's some results of a time. So this is a great big table, and this doesn't show all of the data, but it shows about a month's worth of work on a pick line. And so there were several people working on this pick line, which is a conveyor. That's the photograph. I'll scoot back up here. This is this photograph right here where people are working on a line, a conveyor belt, as trash or recyclables are coming through, and those bins beside them are where they place different types of commodities. So newspaper and office paper and aluminum cans and tin cans and glass, etc., are going in these different bins. And then this table is our analysis, a time study of that whole process. And so on the left column was 1, 2, 3, 4, 5, but the next column, material, you see cardboard and newspaper and office paper and different types of plastic. You see different commodities that we're targeting on this particular pick line. The next column tells us how much we diverted that month, and then the next column is that in tons, and tells us what percent diversion, what percent of the total waste stream did that represent. And then we go a little further. We look at the average weight of the items that are picked. So cardboard, a pound. Newspaper, about 1/4 of a pound. Office paper, 1/10 of a pound. This is just based on random sampling to identify how much each of these picks weighs. And then how many picks are required. So in order to, for example, the first item, cardboard, we diverted 143 tons, or 286,000 pounds. If that weighs a pound each, it took 286,000 picks, or individual reach out, grab it, put it in a bin. And so then, not shown here, we're able to apply cost to that. We know how long does it take to make that pick, because we've done a lot of video analysis on this particular site, and we can apply labor costs and equipment costs to those picks. And so we can actually put a cost to the cardboard. How much of our labor time is it taking? How much material are we getting? What's that worth when we sell it? And what is the overall cost of doing that work? And then we can go through and identify where we get the most bang for the buck in terms of diversion. Now, money is not the only aspect. Sometimes we're mandated to do certain diversion, reach certain recycling levels. And so, excuse me, in that case, we may want to focus on those items that provide the highest percentage of diversion. Or we may be looking at trying to make revenue with this, and so we have to focus on where the revenue is. But a detailed commodity by commodity, almost pick by pick analysis of a recycling facility can really help you pinpoint where those costs are, where you're making money, where you're not, and where you're getting the most diversion for your investment. So this is just kind of a picture, partial look at how a recycling facility can be optimized. Here are some common MRF issues, material recovery facility or recycling facility, some common issues where we just aren't efficient. We're not moving right in terms of if we have to pick up cardboard and we have to turn around 180 degrees to throw it in a bin, that doesn't work. Even the way that you set up the belt, the speed of the belt, if you're working in a recycling facility, what you pick first, and generally you'll want to pick the big things, and so you'll find as the belt comes up and hits the pick line where the people are lined up, we want to pull the big stuff off first. We want to get the cardboard and things out of there so that that's out of the way so we can see what else is in there, and also get the bulk of the material off the belt, or the most material off as quickly as possible. And also, once that material is pulled out, where do we stack it? Where do we put it until it's baled? Where do we store the bales? How often do we get those bales out and sell our inventory? Those kinds of things can become traditional inefficiencies We've seen transfer stations, for example, that began recycling, even though the transfer station was not initially designed for recycling. It was designed only as a transfer station. We see those kinds of facilities where the material gets moved clear around the building and stored on the other side because there's no good access. There's not a door in the building. There's no way to get it there. And so sometimes just stepping back and looking at the overall material flow of a facility can help identify those inefficiencies. Okay, now you probably recognize that these same concepts would apply to a transfer station. Let's take a look at some detailed analysis from a transfer station. We tracked specific performance in this example of the individual drivers. And again, not to rate the drivers and say, hey, you're a good employee or you're not. That's never the point of these assessments. It's to look at the process and see what is possible. How good is someone doing, and can we get everyone to work at that level? And here's some of the initial data. This shows the loading time for the driver. How long does it take per load for drivers to process? And this includes loading, hauling, dumping, and returning. So a transfer truck being loaded at the transfer station, driving to the landfill, unloading, and then returning to the transfer station. These are times. And so we can say on average, looking at this, probably takes a little under 2 hours, probably about 100 minutes per round would be an average. But we got some more detailed information. We broke this down to just look at what is the time just from the landfill to the transfer station. How does that work on the way back from the landfill to the transfer station? And we broke that down per driver. We have 4 different drivers, and they're categorized or subdivided into zones A, B, C, and D. What we see is the first driver, A, has consistently pretty low times, as does the last driver, D, and we see that B and C take longer. And so we actually went with the trucks. We followed the trucks and we watched their route, and part of it was the way that they just managed their driving. They worked with lights and traffic, and they were working, every decision they made was working toward getting back to the transfer station quickly. Here's another look at that same information. This is the time they spent at the landfill. And these are different groups. We have A through E drivers here. We've got 5 different drivers represented, 5 different trucks. And we identified that the time that they spent driving at the landfill and dumping at the landfill varied considerably. Now, some of the dumping variation was due to different types of trucks, maybe a live floor versus tipper versus a chain type unloading system. But even the driving time varied some. And so that tells us that we've got some folks who are more aggressive or more efficient or spend less time visiting and more time or more focus on getting it done. This is another analysis of that. And this chart, the legend at the bottom, shows 4 different aspects, 4 different categories. The load, tarp, and wait time, the time at the landfill, the time from the transfer station to the landfill, and the landfill back to the transfer station. And so we went through hundreds of different individual loads, and we picked the slowest of each one. What's the highest time, the longest time that it took? And that's represented on the first bar chart on this graph. And we see that if we took the worst case, it would take over 5 hours to make that run. If we took the lowest of every aspect, we find it takes just about an hour. And if we take the average, we see that it's just over 100 minutes, just under 2 hours on average. And so by doing this, by looking at the data this way, we can identify what happened when we had these very quick components. When the load, tarp, and wait time was fast, what happened? And here's an example of how that shook out. We found that one particular driver was just generally quicker than everyone else. And here's how he would do that. He would pull into the transfer station to be loaded. He would pull his truck into the loading area. And then he would go take a break and use the restroom. When he finished his break, he would come out. His truck was loaded. He would get in and he would go. The other drivers would come into the transfer station. They would park somewhere other than the loading area. And they would go take a break and go to the restroom. And when they got finished with their break, they'd come get back in their truck. They'd pull it into the loading area, and then they'd sit in the truck while it was loaded. And then once it was loaded, they would drive to the landfill. And so these folks were, for either intentionally or unintentionally, losing a lot of efficiency in their process. And so by looking at this in detail, breaking it down load by load, actually driver by driver, we can find out what's the best that it can be, and what are those folks doing, or whoever's doing that, to achieve those top performance activities. We also saw some variation in driving time. And take a look at this. Different trucks, different driving times. Maybe some variation due to different things, but again, we see that some are just on average faster than others. This is the payload that we saw. Payload is all over the place. This is a problem. And so when you see payloads going out, maybe averaging 18 or 19 tons per load, but then you see some that are higher and some way lower, that kind of variation is a problem. And sometimes with waste, we're just going to have that. Different loads of waste will just have different densities. But when we see this kind of variation, it tells us that there is a problem. Something in the system is not consistent. And we saw some variations in day-to-day, that certain days of the week we had higher payloads. That could be a result of the routes coming in. We also found that on a given day, that as we went through the day, the payloads generally, this is an average, the payloads generally decreased. Now, what does that tell us? It could be that the waste stream is changing coming into the transfer station. It could be that folks are just putting less effort into trying to gain a full payload. It could be a lot of things, and so we have to look a little bit deeper. But when we take this kind of data and we look at it from different perspectives, we just have things jump out that help us identify that. Something else that's important at a transfer station, at a MRF, sometimes at a landfill, even a compost facility, is to develop a mass diagram. And the mass diagram measures the amount of material that's at each stage of the operation. So, for example, at a transfer station where material comes in, it may get pushed or sorted, put into trucks or put into a compactor if we're sending out compacted loads. We may find that there are certain bottlenecks. One aspect or one point, one step in that process may be able to accommodate less tons per hour than another one. And so we see a change. Now, this chart right here shows a mass diagram for a transfer station. And it's set up to cover an entire week. And it shows how much waste is on the ground in the transfer station, on the floor, waiting for the loader to do something with it. And this particular transfer station, that waste was pushed into a compactor, and it was compacted into a big semi-load and then hauled to the landfill. And so we looked at three different things. We looked at how much waste at any given time is on the floor waiting for the loader. We looked at how much waste at any time at the next stage of the operation was waiting to get into the compactor, and then how much waste was waiting for a transfer trailer. And we found that we're never waiting for transfer trailers. That's not a bottleneck. We can get transfer trailers in way faster than we can produce trash. We also found that waiting for the loader was cyclical. We had times during the day when it was busy and it would slow down, and it was very, very consistent, almost a mirror image day to day. But the key thing is that we found that waiting to get that waste pushed into the big compactor so it could be compacted for load, that's the bottleneck in the system. And we also found that by the end of the week, we had sometimes over 300 tons of waste stockpiled waiting to get to the compactor, which required, as you can see, work on Saturday and Sunday to get caught up. And so if there's an area to focus on in terms of efficiency or process improvement, it would be the compactor aspect of this whole system. So a mass diagram just tells us how much material is being processed and also is backed up at each stage of the process. A course summary identifies inefficiencies and solutions. It establishes benchmarks to track your performance. Sometimes there's on-site training to help with that transition and get folks used to doing things in a different way. I'm going to go through the next couple of slides here. We have a poll question. This is our last polling question. If you guys could answer this, give us a feel for kind of where you feel your system sits. And Sarah, I'll hand this over to you.
Okay, great. So you guys should see that last poll box pop up. And again, this is just kind of a, gut feeling where you feel like your specific operation is in the efficiency kind of scale here. So I'll give everyone a few seconds to get an answer locked in. Okay, so we're at about 75%. I'll give everybody about 5 more seconds to get an answer in. Okay, so I'm going to go ahead and close the poll. And Neil, you should see those answers pop up.
Okay, well, we see that most facilities appear to be somewhat efficient, and I think that's probably typical. What we normally find is that facilities aren't broadly inefficient. There may be some inefficiencies out there, but generally most things are being done right. We normally find that there are some key things that just aren't working, and since it's a holistic type of a relationship, those inefficiencies can affect everything. But this is pretty typical. This is what we normally would expect to find, and normally when we do an assessment, this is sort of the result. I'm going to go past the last slide here. I put a couple more things here. I want to just show you something. This is not on your handout. It will be on the piece we'll resend this handout. I added a couple of slides here. Here's a subtle example. You know, we talked earlier in the case of a landfill of the issue of not getting good real-time feedback or not looking at the operation in enough detail. And one of the things that many landfills do is track their airspace utilization factor. How much waste are they packing into a given amount of airspace? And that's usually done on an annual basis. And so annually, we might track those numbers and find that we're consistently getting the same numbers, and so that makes everybody feel good. But when we zero in and look at specifics, look at the operation in great detail, here's one of the things that we typically find. Loads like sheetrock and plaster and stucco or shingles are just randomly dumped. And pretty often, if you have a spotter at your landfill, that person is just standing there pointing for trucks to dump someplace without a lot of perhaps thought going into how that affects the operation. So those loads that contain those materials, sheetrock, plaster, stucco, and shingles, they're hard for the dozer to pick up. Because the material is heavy, it's flat, and for a dozer to really clean the deck, to clean the tipping pad, it has to drop down into the dirt and shave some soil off in order to pick up all of those flat, heavy objects that are in a load like that. Over the course of a day, with the dozer picking up those kinds of loads and pushing some soil into the cell with every push, you might, just for example, typical, you might find that we need 5 scraper loads a day on the deck, on the tipping pad to replenish the soil that was pushed into the cell. If your airspace is worth $10 a cubic yard, that means that dozer has pushed $1,000 worth of soil, a cost of $1,000 in terms of airspace, into the cell. That happens every day. But imagine if the spotter recognized that those hard-to-gather loads are hard to gather, they're hard to push, and took care to place them very close to the cell where they need to end up. And then, on top of that, looked for sweeper loads. That's what I call those, but loads of brush or soft trash or other material that the dozer could push, keep the blade up off the ground a bit, and push those sweeper loads across and use the load itself. In this picture here, use that bit of brush to sweep the material into the cell so that less soil is pushed in inadvertently, but the deck is still cleaned. If you could save half of that soil, that's $500 a day in airspace savings. That's $150,000 a year for a mid-sized landfill. Run those kind of numbers across the life of your site. And that's, I wanted to include this just to give a picture, kind of an idea, a perception of how zeroing in on the details of your operation can start paying back big time in terms of efficiency and cost savings. So I'm going to go back up to here. Thank you for attending. Here's some contact information. And if anyone has questions, that sounds like this is the time to do that. Or if you have questions and you don't want to share that with the group, you can sure email or contact us later, Sarah or I, and we'll help you out with any questions you might have. So
okay, yeah, so if anybody has questions, if you want to click the raise your hand button or send me a quick chat. Neil, I will go back when we were talking about having the clean out area at the tipping face, and
right.
One of the questions was about safety of that. So maybe you could just touch on that briefly.
Well, that's an issue. If there's a dangerous location on your landfill, it is the unloading area. It's where people are on the ground and they're close to trucks and they're close to heavy equipment. And absolutely, that is the highest risk area on your landfill. So we're certainly not saying that they should clean out next to the bulldozer. What we normally try to do with something like this is that, again, here's a traditional picture. We see a landfill that has perhaps an unloading area that's wide enough for 5 trucks. And so during the peak times of day, that may not be wide enough to allow the drivers to unload and clean out right there without creating a long line or creating a pressure for the dozer operators or the compactor operators to sneak in there and push those loads out of the way while somebody's cleaning out their truck. So that's an issue. What we normally find, and again, this whole picture is a holistic picture. You can't fix one thing without affecting something else. We normally find that by changing the layout of the daily cell, and typically making it somewhat larger, and utilizing alternative daily cover in a way that complements that, not so we have a bigger face and more mess and use more cover soil, but by utilizing ADC, we often can find that we can flip-flop from one part of the unloading area to another, meaning that for the first, maybe we start on the left side of the tipping pad and we have room for 5 trucks to unload there. And 5 trucks unload while the dozer's working on cleaning up the right-hand side of the pad. And once those trucks have dumped and they pull out, the dozer shifts over to the left side and starts cleaning those, and now the spotter directs trucks to dump on the right-hand side. So we keep the trucks and the tractors and the people separated so we don't have those conflicts. Some landfills, you can't do that. Maybe having a larger unloading area creates too much litter or creates other problems, but typically the whole concept, the traditional mindset that we must keep a daily cell surface area as small as possible comes primarily from the time when we had to cover only with soil, and so a smaller face meant we used less soil. That's changed. We have many different types of alternative daily cover out there. Cost is way less than using soil, and it gives us a lot of flexibility to change some of these things. So certainly in a congested area, I'm not saying keep the drivers in the face at the edge of the tipping pad cleaning out where there's a risk. But by changing other aspects of the operation, those things can be made to work. So, and I see we had a couple of questions about that, about the queue length and about the safety.
So does anybody have any other questions before we wrap up? If you want to send me a quick chat, or you can use the hand icon.
I see that Mary Jo stated. Mary Jo, I know about your operation that 200,000 is your whole budget. So I didn't give the right I didn't give the right categories in the polling questions. So I apologize for that. I do recognize that some operations are very limited on budget. And I think, Sarah, the polling questions are going to be the results. Those will be part of what we send out later. Is that correct?
Not usually, but if anyone is interested in getting kind of a summary of those polling questions, just shoot me a quick email and I'd be happy to share that information with you. It might be helpful to for whatever reason you might need it. So definitely I can get that information out if you're interested.
Okay, so Mary Jo, in that case, just contact Sarah or anyone else who wants that, and we'll get that to you. And I see, John Monaco, we have a question about a comment that your clean-out area is away from the active face. And that's fairly common, and for the reasons that we talked about in this course, that it's often done that way. What we find is that adds a significant cost to the landfill operation. It doesn't really get the route trucks out faster. It just gets them off the tipping area quicker, but they hang out at the landfill actually longer by having a separate clean-out area. So again, that's something that has to be done holistically. You have to look at how changing from a clean-out area to no clean-out area is going to impact the other parts of the operation, and then make modifications to keep folks safe, to avoid having longer queues, longer wait times. But it can be done. Those kinds of things are regularly solved.
I see one other question about the copy of the presentation. And yes, we recorded the webinar today, and you guys will all get an email with the webinar recording and the handouts and any other materials to go along with it. So look for that within the next week. We had another question come in, Neil. How do most people handle sludge at the tipping area?
Okay, that's a great question. We're working with the landfill right now. We did some operational assessments, kind of a core assessment for them. We're doing some on-site training. One of our guys is on-site actually today, helping them implement and sort of retraining the crew on how to how to make these efficiencies work for them, and they get a lot of sludge. And typically what was happening at this particular site, they would get a load of sludge, biosolids, and they would push it off to the side, and they would bring in transfer loads full of wood chips, and they would use the wood chips to bulk up the biosolids, kind of to sop up that material, kind of spread it out and bulk it up, and it wasn't wet. You know, it passed the paint filter test, but it's still wet. And they would use those wood chips, so they're adding a non-necessary waste into the waste, and they're bringing more material into the landfill to take up airspace just to bulk this up. And one of the things that we did with them was to make their cell larger. We used a pancake system, and we made their active cells larger, and we made the area that the compactor worked on horizontal or flat. And then those biosolids were layered in there, very, very thin. When a load of biosolids came in, we'd spread it out just as thin as it could be and mix that with trash. And so virtually every layer of trash has some biosolids mixed with it. And by integrating that, they're getting some dynamite waste densities, and they're able to absorb all those biosolids into the waste stream. And so there are issues with that. You know, biosolids or sludge can make a mess, but it can also be a tremendous boost to your density, because the moisture in the biosolids or in the sludge can help the paper, the cardboard and paper and that type of material that's in your waste compact much, much better. So I think that though it's going to be a problem, definitely there are ways to do that, and a lot of savvy landfill managers, you know, would give anything to get loads of biosolids or sludge into their landfill, because they're looking for the moisture to help them get better compaction rates.
Okay, so do we have any other last minute questions coming in? It doesn't look like it.
Well, I'd like to thank all of you for attending. If you have questions about this, we have other information. We could give you some case studies or some examples of how you could apply this kind of thing at your facility. And again, we have done core assessments, more than 50 of them in the last 5 or 6 years. We're constantly doing core assessments around the country for different types of waste facilities, and we always identify a lot of inefficiencies, and there's definitely a quick payback on that type of work. And it's just a matter of getting past the things we talked about, those traditional inefficiencies that we all have, and getting a fresh look at that. So if you have questions, let us know, and thank you all very much.
Thank you so much for attending. And once we close out the webinar, there'll be a quick survey that pops up, if you don't mind.